Lesson: Machine translation and language generation. Machine translation and language generation are two pivotal components of natural language processing, a field that has seen substantial advancements due to the proliferation of artificial intelligence technologies. Both machine translation and language generation serve as crucial tools for breaking down language barriers and automating content creation, respectively, offering significant opportunities for professionals in the AI and NLP domains. Machine translation involves the automatic conversion of text from one language to another, an area where statistical and neural network-based approaches have greatly enhanced accuracy and fluency. The transition from traditional rule-based systems to statistical machine translation marked the beginning of this evolution, with SMT leveraging large corpora to predict the likelihood of word sequences. However, the advent of neural machine translation, particularly those based on deep learning models like recurrent neural networks and transformers, has revolutionized the field. NMT systems are capable of capturing context and long-range dependencies in text, significantly improving translation quality. A prime example is Google Translate, which switched from SMT to NMT in 2016, resulting in a notable increase in translation accuracy. The transformer model, introduced by Vaswani et al., has become the backbone of modern NMT. Unlike RNNs, transformers use self-attention mechanisms to process entire sequences simultaneously, allowing for greater parallelization and efficiency. This model underpins many state-of-the-art translation systems, including OpenAI's GPT and Google's BERT, which have further refined translation capabilities by improving contextual understanding and reducing errors. Professionals looking to implement machine translation solutions can utilize frameworks such as TensorFlow and PyTorch, both of which support the development and deployment of NMT models. These frameworks provide pre-trained models and libraries, such as Hugging Face's transformers, which simplify the integration of translation functionalities into applications. For instance, Hugging Face offers a wide range of transformer models that can be fine-tuned for specific language pairs or domains, enabling customized translation solutions. Language generation, on the other hand, focuses on producing coherent and contextually relevant text. This capability is critical for applications such as chatbots, content automation, and creative writing. Language models like GPT-3 have demonstrated remarkable proficiency in generating human-like text, driven by their ability to understand and predict language patterns. GPT-3, with its 175 billion parameters, showcases the power of large-scale language models in generating diverse and contextually appropriate text outputs. A practical approach to language generation involves using frameworks like OpenAI's API, which allows for seamless integration of GPT-3 capabilities into various applications. By leveraging this API, developers can create sophisticated NLP systems that automate content creation, enhance customer service interactions, and provide personalized user experiences. Additionally, the API's flexible interface supports fine-tuning and customization, enabling professionals to tailor the language model's outputs to specific use cases. Moreover, the ethical considerations surrounding language generation must be addressed, particularly regarding biases and misinformation. Models like GPT-3 are trained on vast datasets that may contain biased or false information, leading to outputs that reflect these biases. It is crucial for professionals to implement strategies for bias mitigation, such as incorporating bias detection algorithms and curating training datasets to improve the fairness and reliability of language generation systems. Real-world applications of machine translation and language generation are abundant and diverse. In the healthcare sector, for example, machine translation facilitates communication between patients and healthcare providers who speak different languages, thereby improving access to medical services. Language generation can assist in creating personalized health reports and patient education materials, enhancing patient engagement and understanding. In the business domain, machine translation enables companies to expand their reach to global markets by localizing content efficiently. Language generation supports marketing efforts by automating the creation of promotional materials, product descriptions, and customer responses, leading to increased productivity and consistency in brand messaging. Statistically, the demand for machine translation and language generation technologies continues to grow. According to a report by Markets and Markets, the global machine translation market is expected to reach 983.3 million by 2022, driven by the increasing need for cost-effective translation solutions and the rise of global e-commerce. Similarly, the language generation market is expanding as industries recognize the value of automating content creation processes to meet the growing demand for personalized and timely communication. In conclusion, machine translation and language generation are integral components of NLP, offering transformative benefits across various sectors. By leveraging advanced AI models and frameworks like Transformers, TensorFlow, PyTorch, and OpenAI's API, professionals can develop robust translation and language generation solutions that address real-world challenges. However, it is imperative to remain vigilant about ethical issues, particularly concerning biases and misinformation, to ensure the responsible deployment of these technologies. As machine translation and language generation continue to evolve, their potential to enhance human-computer interaction and facilitate global communication remains boundless.